All right, so yesterday we left off having already set up the inequalities to represent the constraints. So what are constraints again? Limits, right? So this one, they had to have at least 9.5 yards of fabric and up to, they could spend up to $110 of fabric. So try to find what that limit is. That's usually alone on one side of the inequality symbol. And then the symbol, really think about like your relationship. Where does the opening always face? The alligator mouth. The bigger number, right? It wants to eat the bigger number. So when we're trying to figure out, oh, what symbol do I use for at least? Think, can I spend more than 9.5 if it's at least 9.5? So that is why we put the inequality symbol opening towards the other side, not the 9.5. Because you can't have more than 9.5 if it's at least, because you have exactly the 9.5. So that's why we chose the equal to symbol. So greater than or equal to. For the up to 110, could I spend more than 110? So that's why we have the opening facing the 110. That's basically the highest it could be. On the other side, it would have to be either equal to or less than that. So that's like your tip for knowing the symbols. Don't memorize them, just think about it like common sense wise. And then as far as like what to use for the left side or whatever side you're putting it on, keep your dollar amount with your dollar amount. So usually play a key there for the dollar amount total. And then usually I'll say like 90% of the time, the other inequality is something super simple like X plus Y. It just depends what you made your variable. For us, X was yards of light fabric, Y was yards of dark fabric. So then for the one for the dollar amount, you times it by the cost, that gives you how much you spent. Make sense? All right, just recapping what we discussed yesterday. And then you could graph it yourself by hand, or you can use Desmos to figure out what your graph should look like. And this is what we determined. I don't think in this class we answered 2 or 4, correct?
Yeah.
We did?
No, we didn't.
Okay, so then take a moment. I would say about a minute. You can use Desmos if you wish, or you can just use the graphs that are printed on your paper. And number 2 would be for the length constraint. Select all the pairs that satisfy the length constraint. Number 4, you're picking all the pairs that satisfy the cost constraint. So how do I know if it satisfies it or not? If it's in the shaded area or if it's on a solid line. Because sometimes we do have dashed lines, right? If it's on a solid line or in the shaded area, it isn't. So try that for about a minute. So is 5, 5 a combination that satisfies the length constraint? All right, let's see. 5 would be like in the middle of here and in the middle of here. So yeah, it looks like it's on the line or in the shaded area. If you really want to know, like if it seems a little iffy to you, check in Desmos. All right, I don't want you to fully rely on Desmos, but it is a great tool that you have access to. So if I type in that length constraint, and then I also type in that coordinate, is it in the shaded area? Yeah. So if it looks a little weird on your paper, you can't tell for sure, check it in Desmos. So yeah, that one is a combination that satisfies the length constraint. What about 2.5, 4.5? Let's see, so it'd be like here-ish, not in the shaded area, so not that one. What about 7.5, 3.5? Yes, that would be here on the X and about here on the Y. So in the shaded area. And then lastly, 12, 10. Yes. All right, that's how you can track. Just remember in coordinates, it always goes in the order X, Y, so make sure that X. All right, number 4, we're looking for stuff that satisfies the cost constraint. So 1, 1, would that satisfy it? Yeah, it'd be about there. What about 4, 5? Yeah. Looks like it. 8, 3. Yeah, looks like it's right on the line. I might just have to go back there to be sure. And check that one in decimal. Close. You checked it. And then 10, 1. I don't know. It looks like it. Yeah. So 10 would be here, 1 would be like right there. Anyone check that one? Okay, they're all satisfying it, right? Question? Okay, let me see my key. Yeah, it has all of them except 8, 3. So let's double check that one. That's what the key on the book says. So let's know for sure. That one is the one that I wasn't sure of because of how close it was to like that boundary. So if you type it in 9x plus 13y, and then it has to be less than or equal to, so those buttons are down here if you need them, less than or equal to 110. So if I type in 8, 3, I might have to zoom in. It does look visually on the line, but if I zoom in closer, it is not. All right, so that's kind of deceiving, but you know, we knew to probably check that one because of how close it was. So yeah, cross off 8, 3 if you circled it. There is also a way to check it algebraically, because 8 we would plug into where? Into the X. Oops, that's not what I meant to do. Plus the 13 times, what did we say Y is? 3. We get 111. Is 111 less than or equal to 110? So that's why it doesn't satisfy it. We're spending a little bit too much. Our limit was 110. Good. Any questions? All right. So then I think we can move on from number 6. What does the pair of numbers represent? So what does X represent? Good. So the X is the yards of light fabric. I'll just abbreviate fabric. And Y is the yards of dark fabric. So in any of these combinations, like for the length, we could do 12 light, 10 dark. Or like for the cost, we could do 10 light, 1 dark. Now, aren't both of them constraints? Doesn't she need to meet both constraints in this situation? Yeah, so really, if this is a system, which we are looking at systems, and I have 2 sets of constraints, I should really be looking at where both constraints are met. So you can do that by graphing by hand. You can do that by graphing in Desmos. I believe on your constructed response, you do have to graph a system by hand, or at least an inequality by hand. But if I type in both constraints, where is the like possible combinations that meet both constraints? Where both are highlighted. So really in this situation, it would have to be here, where it's like the darkest. So normally we would graph these by hand and you would look for the overlapping shaded area if both constraints need to be met at the same time. Make sense? Could it be on the solid line? Yes. So anything on the solid line, as long as it's in the overlapping shaded area, so I wouldn't pick like this point over here, because that's not where they overlap. But yes, anything where it overlaps and it's on the solid line, meets both criteria. Question? Okay, so then actually do answer number 6. Find at least one pair of numbers that satisfies both constraints. You can use my visual on the board, you can type it into Desmos itself. But answer number 6, a pair of numbers that meets both constraints. All right, someone give me a pair. All right, I heard 10, 0. Let's see if it's in that shaded, overlapping shaded area. Is it? So then if you don't have anything yet, you could put 10, 0 as an example. So here's I'll put my answer to number 6 over here. What else could satisfy it? Gavin? 10, 1 is in that shaded area, overlapping shaded area. Diamond. Let's see. All right, I'm trying to zoom in. Yep, that works. All right, so questions on solutions to systems of inequalities. Good. If you want to write that somewhere, solutions to systems of inequalities are overlapping shaded areas. All right. So write that somewhere, whether it's on the back, we're done with the 2.24, it's just this part. So solutions to systems of inequalities are coordinates in the overlapping shaded areas. All right, so write that down, and then we're going to move on to 2.25.